We're going to look at lesson 1.4, which has to do with sketching of graphs of functions. Before we start the lesson, we're going to recap and recall some of the terminology we've learned. Intervals of increase are intervals within a function's domain where the y values of the function get larger when you move from left to right. Intervals of decrease are the intervals within a function's domain where the y values of the function get smaller as you move from left to right. An odd function is any function that has rotational symmetry about the origin. And algebraically, all odd functions have the property that f of minus x equals minus f of x. An even function is any function that is symmetrical about the y-axis. And algebraically, all even functions have the property that f of minus x equals f of x. A continuous function is any function that does not contain any holes or breaks over its entire domain. A discontinuity is a break in the graph of a function, and it's called a point of discontinuity. A new word we're going to learn is turning point. So if you see this graph here, you can see that A and B are turning points because at those points the function changes from an increasing function to decreasing function, and at B changes from a decreasing to an increasing function. So A and B are turning points in this graph. Also recall the transformation of functions and what A, K, D, and C represent. A represents a vertical stretch, and if A is less than 0, there's a reflection in the x-axis. It's also called a vertical reflection. K and D are what relates to horizontal changes. K means that there is a horizontal stretch by a factor of 1 over K. And if K is negative, there is a reflection in the y-axis or a horizontal reflection. If D is greater than 0, the graph of the function shifts D units to the right. If D is less than 0 or it's negative, then the graph of the function shifts D units to the left. C represents vertical translations. C greater than 0 means that there's a shift of C units up. C less than 0 means a shift of C units down. The order in which transformations are applied is important. First, when you're looking at transformations, you look at the horizontal and vertical stretches of compressions and any reflections, and then you look at the horizontal translations. So here you have an example. You're given a function f of x equals square root of x. Find the equation and sketch the graph after the given transformations. So these are the 1, 2, 3, 4, 5 transformations that have occurred to f of x equals square root of x. Vertically stretched by a factor of 2, and a reflection in the x-axis. So these both are have to do with the vertical part, right? And then this shift down is also a vertical change. Whereas a horizontal stretch by 3 and a shift of 2 to the right, they're all horizontal changes. So how does that affect the way a function looks? So let's put those changes in. Because there is a vertical stretch by a factor of 2, you have an A value of 2. Because there's a reflection in the x-axis or a vertical reflection, this becomes negative. And then under the square root, there is a K value. It's stretched by a factor of 1 over, I'm going to change this horizontal stretch. I'm going to make it a different number here. Let's make it by 0.5. Okay. And so, just that look neater. I'm going to change this value here and make it horizontal stretch by a factor of 0.5. So then that's 1/2. So, you find the reciprocal of that, which is 2 here, will be the value of K. Brackets X, shifting 2 units right means minus 2. And then there is a shift of 1 unit down. So that will be outside of the square root, so minus 1. So you can see now that these are the 1, 2, 3, 4, 5 transformations. 1, 2, 3, 4, 5 transformations to the parent function. Then they're asking you to find the equation and sketch the graph after the transformation. So we can try to create a table of values and use a table of values to to come up with the values and plot the function. So you can assign values to x, find the values of the function for those values of x and plot it. Or you can map it. So what you can do is, well, if the original function had x and y values, then as per the changes that have happened due to the transformations, what happened to all the x values? Well, every value is horizontally stretched by 1/2, so every x value is divided by 2. And then it's shifting 2 units to the right, there is a +2 happening to it. For every y value, there is a vertical stretch by a factor of 2 and a reflection in the y-axis. So there is -2 times y happening to it, and then it's shifted 1 unit down. So it's -2y minus 1. So if you're using this method, what you can do is take the points you have from the function f of x equals square root of x. We know the values of x for that. The x values we are going to take are, when x is 0, y is 0, when x is 1, y is 1, when x is 4, square root of 4 is 2, when x is 9, square root of 9 is 3. And we are going to now take the same numbers and do these transformations to them. So x divided by 2 plus 2 for the x values, and -2y minus 1 for the y values. And the numbers we get are 2, 2.5, 4.5, and 6.5. So each one of those values, I divided them by 2 and then added 2 to it, and I got these numbers. And then for the y values, for each of them, you multiply them by -2 and subtract 1, and you will get -1, -3, -5, -7. And then you can take these points and graph them. So 2, -1 is this point, 2.5, -3, 4.5, -5. So 1, 2, 3, 4, 5. 6.5, 1, 2, 3, 4, 5, 6.5. And you come down to 7, 1, 2, 3, 4, 5, 6, 7. And you have these points. So it's starting. You have some points there, and you can just graph the function. So there you have it. This is the graph of the function. Then they're saying if there is a point 10,609, 103 on the parent graph, what would the coordinates be of the image point? So we know that every value x, y in the given function, when it's transformed, it would become x over 2 plus 2 for the x values and -2y minus 1 for the y values. So if you have 10,609 for the x and 103 for the y, divided by 2 plus 2 for the x value, and -2 times 103 minus 1 for the y values, and that works out to 5,306.5 for the x value and -207 for the y value, and those are the coordinates of the image point. Now we have another example. You're given a function f of x equals 3 to the power of x, so an exponential function. Sketch the graph of the function y equals 2 f of minus x plus 1 minus 5. So the transformations that have happened here are not very clear unless you factor out the -1 here. So y equals 2 f of -x plus 1 minus 5. You need to clearly see the k and the d value. So you need to factor out the -1 here, and into brackets goes x minus 1 minus 5. And now you can clearly see the a value, the k value, the d value, and the c value. All right, so this is your vertical stretch. This is your horizontal reflection, because it's a reflection of the y-axis. This is your horizontal shift, and that's your vertical shift. Okay, so what does the actual function look like? The given function is f of x equals 3 to the power of x. So how does the function the new function, let's call it g of x, after transformations look like. These are the changes that are happening to it. So of course you have an a value of 2 times 3 to the power of what's happening to the x. You're going to have a minus of x minus 1, and then you're going to have a minus 5 because there's a vertical shift of 5 units down. So these are the changes to this function, and we're going to now graph this function and see, after that we can state the domain range. So to graph this function we need some points. So we're going to look at the transformations. xy in the parent function becomes, the changes to x are each value becomes negative, and then it shifts 1 unit to the right, so plus 1. And for the y, every y value gets multiplied with 2 times, and then you subtract 5. So in the parent function, f of x equals 3 to the power of x. We can see what happens. We can assign some values. Let's take them from -2, -1, 0, 1, 2. So when these are the values of x, when x is -2, the y value is 0.1. When x is -1, the y value is 0.3. When x is 0, the y value is 1. When x is 1, the y value is 3. The x is 2, 3 to the power of 2, which is 9. So we have these values, and now we're going to see what happens to those in the image function. So every x is multiplied by -1, by a negative, and then 1 is added to it. And for the y values, multiply each y value by 2 and subtract 5. So you get these points. -2. So you get 3 here and -4.8. You get 2 here and -4.4. Then 0 becomes 1, and this value becomes -3. And then for 1 and 3, you get 0 and 1. And for 2 and 9, the points become -1 and 13. Okay, so now that we have these points, we can go to our graph and plot these points here. So let's just move this graph. We actually find that there is a horizontal asymptote for this graph when you plot it. Just plotting those points. There you have -1 and 13. So you can see that there is actually a horizontal asymptote at this graph is an exponential function, and the y-intercept is at 1, and it's always approaching 5, but never, touching or reaching it. So 1, 2, 3, 4. Let's say this is 5. We'll draw a line to show this is our graph, and this is y equals 5, and that is the asymptote. Okay, y equals -5, not y equals 5, y equals -5. So that's the graph of the function. Now we can take the sinusoidal function. Given f of x equals sine x, sketch the graph of the function y equals -3 f of 2 times x minus 45 degrees plus 1. So you can see here that you don't need to work on this equation. You can clearly see the a, k, d, and c values. And you can go straight away to what happens to the x and y values. How has it changed from the sine function when these transformations have happened to it? So you have to sketch the graph. In order to sketch the graph, we need points. In order to get points, we need to take the points from the parent function, which is a sine x function, and then apply the changes to it, and then get the new points, which you can use to graph and sketch the graph of this transform function. So what are the changes that are happening to this? Each x is multiplied by the horizontal value is, the k value is 2. That means it has been horizontally stretched by a factor of 1/2. So you have x, every x value is divided by 2. And then x minus 45 means it has been moved 45 degrees to the right. So plus 45. So those are the transformations for the x. For the y values, every y value is multiplied by -3. And then 1 is added to it. Okay. So now we draw a table of values for the parent function, which is f of x equals sine x. And we know the x and y values for that function. For 0, sine 0 is 0, sine 90 degrees is 1, sine 180 degrees is 0, sine 270 degrees is -1, and sine 360 degrees is 0. So we're going to take these values and create a new table for the values of the image values for the transform function. What would that look like? So when you do these, when you take every x value divided by 2 and add 45, the numbers you're going to get are 45 degrees, 90 degrees, 135 degrees, 180 degrees, and 225 degrees. And then take every y value multiplied by -3 and add 1 to it, and you get 1, -2, 1, 4, 1. So we're going to take these points and we're going to graph the transform function here. So let's say this is somewhere here is our 45. We need 45 degrees. This is our 90 degrees. But actually do it in a different way. If we graphed it differently, we made the scale so that they actually go up by 45 degrees instead of this. So I'm going to do it on a different page. I'm going to graph it so that its scale is different. So I'm going to do it. Because now you can see that the x values are going up by 45 degrees, and so we're going to do that on this graph. So we start at 45, then go to 90, then go to 135, then 180, and 225 degrees. 1, 2, 3, 4. -1, -2. We have 45 and 1, that's this point. 90 and -2 is this point. 135 and 1. 180 and 4, so this is a 4 up there. 225 and 1. So if you take those points and connect them, you can see the graph of the transformed sine function. And the next value there would be 270, and the 270 is going to go back down to this -2, so it's going to be like way down here. So it's going to go like that and then go back up. And here too, we know that just because the pattern at 0, it's going to go up to 4. So it's going to go up like that. And that's how the function is going to look. Okay. So we did the graph now, and we have to now state the domain and range. So domain is x is a real number, because you can take any value over here and that works. The range is that y is a real number such that there's an upper limit, which is it only goes up to 4, and lower limit is only goes as low as -2. So it's -2 less than or equal to y less than or equal to 4. Intervals of increase and decrease. Well, you can see that it's decreasing and then it's increasing, then decreasing, but you have to see that, it's so intervals of decrease 0 to 90, and then from 180 to 270, and so on. And intervals of increase, this actually continues, it just doesn't stop here, there's more intervals, and the intervals of increase would be 90 to 180, and so on. Turning points, well, there are turning points. You can see that that happens at 0 degrees, at 90 degrees, 180 degrees, 270 degrees, and it keeps going on and on. So it just continues. Okay, so now you can practice the questions in the textbook.